What we're going to look at is using the trig identities we have to verify. Now, to do this, you need to have this list of identities with you. You'll learn to memorize them, but we're going to just kind of keep these and use them as we go. So we have our reciprocal identities, and that tells us whether that sine is the reciprocal of cosecant. So we could either write sine as 1 over cosecant or cosecant as 1 over sine. Cosine and secant, same thing, and then tangent and cotangent. So they are reciprocals of one another, and we may use that to replace one. We have the quotient identities. So we know tangent is opposite over adjacent, but we can also say that it's equal to sine over cosine. And then cotangent, because it's the reciprocal of tangent, would be cosine over sine. And then our last set is the Pythagorean identities. We have sine squared theta plus cosine squared theta equals 1. This is also connected to the Pythagorean theorem. And then really modifying this statement, we get the other two, but we leave them in this form for convenience. We get 1 plus tangent squared theta equals secant squared theta, and 1 plus cotangent squared theta equals cosecant squared theta. And so we're going to use these to get these statements that we have to be equal, and we're going to verify with them. Now, just be aware, whenever we get secant, cosecant, or cotangent, I want to change them back to sine or cosine, or just get them to match what I want. Same thing with tangent, cotangent, converting them down, and even with these Pythagorean identities. Now notice it's the squared there, so if we have something squared, it's probably going to point to those. So let's start with some basic ones, and we're going to just get an idea for the steps. So the first thing I have is tangent theta, cotangent theta equals 1. So when I verify these statements, I'm going to pick one side of the equation, work it through, and try to get it to match the other side. Do not solve both of them at the same time, and do not move things from one side to the other. So work with one of them to get it to match the other. So let's look at tangent and cotangent. Well, tangent, we can think of it as using our quotient identities as being sine over cosine, or even it's the reciprocal of cotangent, and cotangent is our reciprocal of tangent, or it's in the identity. So let's do this. Let's change cotangent to be its reciprocal, 1 over tangent theta. Okay, and then that tells us we have, and then by multiplying, we get that tangent theta over tangent theta, which ultimately becomes 1, which matches what we wanted on the right side, 1 and 1. Okay, so that's really all it is. It's simplifying it down using them. Let's do another one here. What if I had cosecant theta, tangent theta equals secant theta? So let's think. Cosecant. We have cosecant on our list is 1 over sine theta. And tangent on our list is 1 over cotangent theta. That probably doesn't help us. But what if we call it 1 over sine theta over cosine theta? Now with that, we can look at multiplying these two fractions, and the sines become 1. We get 1 over cosine theta. Now 1 over cosine theta, its reciprocal is secant theta, so we get secant theta equals secant theta. Now let's look at tangent theta, cosine theta equals sine theta. So I'm going to change tangent into nicer terms. I could call it cotangent, but really I already have cosine and sine, so let's write it there. Tangent theta is sine theta over cosine theta. Bring down the cosine theta. By multiplying, these become 1. I'm left with sine theta equals sine theta. Let's do another one. Cotangent theta, sine theta equals cosine theta. We see cotangent, we see sines and cosines. Let's change cotangent to be this quotient identity of cosine theta over sine theta times sine theta equals cosine theta. We're not there yet. These multiply out to become 1, so I'm left with cosine theta equals cosine theta, which is what I was looking for. So now I'm going to say 1 plus cosine theta times 1 minus cosine theta equals sine squared theta. So I look at this when I see a sine squared theta. So that might mean the Pythagorean identities might be involved, or could ultimately just be sine times sine. Now, I'm not going to worry about that yet. I'm going to focus on the left-hand side. So on the left-hand side, I'm multiplying these two. Now, back in algebra, if you had a plus b times a minus b, this was a difference of two squares, and it became a squared minus b squared, which really we have the same parts here, so we could write this as 1 squared minus cosine squared theta equals 0. So this really just becomes 1 minus cosine squared theta. I don't know why I wrote 0 there. So this becomes 1 minus cosine squared. Now, is that equal to sine squared theta? We don't have anything written there like that, but if we look at our Pythagorean identity, if I took my Pythagorean identity and rearranged it and isolated sine, which I can do, I can isolate, move that over, I can make this into sine squared theta equals 1 minus cosine squared theta, which I now want to replace that right here with sine squared theta, which by doing that, our Pythagorean identity, we get sine squared theta equals sine squared theta, which is what we wanted. For our next one, let's go sine theta over cosine theta plus cosine theta over sine theta equals cosecant theta secant theta. So I'm going to work with the left-hand side. Now, I'm going to add these two fractions. They're not like denominators, so I have to get them common denominators. And my common denominator for them is going to be sine cosine. So I'm going to multiply this fraction by sine, top and bottom. So this becomes sine squared theta, cosine theta, sine theta. And this fraction, I'm going to multiply the top and the bottom by cosine, cosine squared theta, and sine theta, cosine theta. Okay, now I can combine them, and my numerator is sine squared theta plus cosine squared theta over cosine theta sine theta. This is a Pythagorean identity. This becomes 1 over cosine theta sine theta, which we can now write as two separate fractions, 1 over cosine theta times 1 over sine theta. Now that, I can now look at the reciprocal, because why do I want fractions here? 1 over cosine theta equals secant theta. 1 over sine theta is cosecant theta, and that equals what we're looking for, cosecant theta secant theta. So we combined the fractions with like denominators, used our Pythagorean identity, and got it down to our reciprocals. Last one we'll look at here is tangent theta plus cotangent theta over tangent theta equals cosecant squared theta. Now, I see a fraction here. I'm going to break it into two fractions because I have a denominator. I can make it tangent theta over tangent theta plus cotangent theta over tangent theta equals cosecant squared theta. Now, this becomes 1. Cotangent theta and tangent theta, well, that one's a little bit different. So let's think of it as cotangent theta times 1 over tangent theta. Now, tangent theta is really the reciprocal of cotangent. So I can make it into this. Then I multiply the two together. Becomes cotangent squared theta. Now this comes back to our Pythagorean identities. 1 plus cotangent squared theta is equal to cosecant squared theta, which is what we're looking for, squared theta. Now, as you go through and practice these on your own, some will follow the similar pattern as this, but always keep these things in mind. Pick one side and one side only to isolate. Pick the left side, pick the right side, it doesn't matter, but work your way through and get that side to match. Use the identities that you have. You may have to rearrange. Sometimes the Pythagorean, we can move the ones and the terms over, but keep in mind those have to do with squares. And when you get terms like these, get rid of reciprocals, go back to just the trig function without the fraction, and if you see tangent and cotangent, you probably want to use the quotient. But you're only going to get better with practice, so good luck.